Welcome to Session 18, Special Systems and Modeling. This lesson strengthens algebra that remains reliable when the numbers or representations become unfamiliar. You will learn to classify systems with 1, 0, or infinitely many solutions, to use parameter relationships to predict system behavior, and to interpret intersections as decisions rather than isolated coordinates. Treat these as connected habits. Keep a pencil ready. We will build a visual model, use a repeatable process, solve a demanding example, diagnose an error, and finish with a checkpoint. Start with this picture. Intersection count is the graphical meaning of a system's number of real solutions. Algebraic elimination and graphical intersection answer the same question. Matching relationships overlap. Incompatible parallel relationships never meet. The key distinction is this: classify systems with 1, 0, or infinitely many solutions. Then connect it to the second goal. Use parameter relationships to predict system behavior. Correct methods begin with correct interpretation. When a problem looks different, look for the same mathematical structure instead of an identical example. That transfer makes the skill durable. Step 1. Compare coefficient ratios before full elimination. Identify the object being changed and the requested result. Step 2. Eliminate one variable and interpret the remaining statement. Use a separate line so signs, units, and restrictions stay visible. Step 3. For parameters, identify the value making complete equations proportional. Work efficiently without skipping an operation. Step 4. State what the solution count means in context. Whenever possible, verify with evidence independent of the original working. Signal 1 is all coefficients and constants proportional. Respond by remembering. The equations describe the same relationship. Name the response before calculating. Signal 2 is variable coefficients proportional, but constants are not. In that case, the system has no solution. The form tells you which tool fits. Signal 3 is cost equations intersect. Remember, the point is a break minus even quantity and cost. This separates plausible from valid answers. If you cannot name the signal, slow down. Deliberate classification is faster than repairing rushed algebra. Here is the challenge. For what k do 3x plus 2y equals 12 and 6x plus 4y equals k have infinitely many solutions. Restate the target and identify the most important part of the routine. The first move is, the second equation's variable coefficients are twice the first equation's. This changes the form without changing the meaning. Next, for identical equations, the constant must also double. Keep the relationship visible and apply the operation to every required term. Now audit distribution, signs, copied values, and restrictions. A brief midpoint check is cheaper than rebuilding the solution. Continue with the third step. Thus k equals 2. 12 equals 24. State what the transformed line tells you. Complete the argument. If k24, the left sides are proportional but constants conflict. This is part of the solution, not decoration. The final answer is k equals 24. Compare it with the requested variable, expression, unit, interval, or classification. Verify from another direction, substitute, compare representations, inspect units, or test a boundary. Prove that the result satisfies the original conditions. Try this checkpoint without copying the example. If elimination produces 0 equals 7, how many solutions are there? Decide which mathematical fact controls the answer. Write one line of reasoning before you commit. A visible decision is easier to inspect and correct. A focused hint. A contradiction means no shared point. Use it to repair your setup rather than guess. An accepted answer is 0. Explain why it works and name the first step that would expose a common error. The central message is, classify systems with 1, 0, or infinitely many solutions. Combine it with the discipline to use parameter relationships to predict system behavior. Finish by remembering to interpret intersections as decisions rather than isolated coordinates. This turns a calculated result into a justified answer. Reflection. How can proportional coefficients predict both no solution and infinitely many solutions? Name the error specifically so you can interrupt it next time. Practice one fresh problem within 4 minutes, including the non-special parameter case. Keep the work readable, check it independently, and carry the routine forward.